Let's take a look at a couple of examples. Hopefully you're getting to watch these worked out in class also, but just in case you're moving a little bit quicker than your peers, I'm going to go ahead and work through these with you. When we're asked to write the orbital notation for an element, one of the first things we've got to do is identify how many protons and electrons are in that atom. When you find magnesium, abbreviated Mg, you're going to notice that it has how many protons? 12. Okay, 12. We've got to remember, why do we always start with the number of protons? Well, because we understand that to determine the number of electrons, it's the same as the number of protons. So there are 12 electrons in magnesium, which means when I look over here at my orbital notation, I should have 12 arrows. Excuse me, you all. According to the off-ball principle, we're always going to start down here. Remember, each one of these little lines is called an orbital. This number 1 right here is referring to the energy level. When I'm looking at this, I see 1s. That 1 is telling me that this is the first energy level and it can hold 2 electrons. I have a total of 10 electrons, so let's go ahead and put in 2 there. 1, 2. Notice that I put them in those opposite spins because of Hund's rule. Now I have 10 left. Next we're going to fill in the 2s. So that's going to be 3, 4, 5, 6, 7, 8, 9, 10. The 2p is now completely full. I've used 10 and I've got 12. So we're going to put the last 2 in this 3s, 11, 12. And that's what we're looking at right there with orbital notation. Every single one of our electrons has been accounted for. We think that we probably know where they go. Now, just to kind of make you think a little bit further, what if I'd asked you to do aluminum? Find aluminum on your periodic table. It's in group 13. And notice that it has 13 electrons. So where would that next electron go if we were showing aluminum? It would go right there in that 3p first orbital, right there. Okay, let's come on down here and take a look at silicon. Step 1, identify how many protons and how many electrons silicon has. It's going to be over there in group 14, period 3, and you'll notice that it has 14 protons. And if it has 14 protons, that means it also has 14 electrons. So here we go. And if I were you right now, I would go ahead and hit the pause video and try doing this on your own, okay? Because you don't know unless you try. So go ahead and hit the pause on the video, and see if you can put these electrons in by yourself. Okay, hopefully you've given it a go. Let's go ahead and put in our 14 electrons. 1, 2, 3, 4. Watch how we spread them out here. 5, 6, 7, 8, 9, 10. Come up here to the 3s, 11, 12. Then we're going to go to the 3p because remember, increasing energy. 4s has more energy than 3p. I've used 12, so I need to go 13, 14. Notice how I spread those two out in the 3p sublevel because of the Pauli exclusion principle. Okay, we want to spread those electrons as far as possible. And that is the orbital notation for silicon. Take a look at bromine. If I were you, I'd go ahead and hit the pause button right here and try this one on your own. Bromine's in group 17, period 4. Hit the pause button and see if you can identify how many protons and electrons are in bromine, and then try to go ahead and plug those electrons into your orbital notation. Okay, bromine has 35 electrons. We always start at the bottom, and we're literally going to count to 35. What you have to remember is in what order. So let's look at this almost like a ladder. We know that we're going to fill them in terms of increasing energy. So it'll go 1s, 2s, 2p, 3s, 3p, and this is where a lot of students get confused because they'll want to fill in the 3s, the 4s, but you actually look at your energy. The 3p has a lower energy than the 4s, so we'll fill in the 3p, the 4s, then jump over here to the 3d, and then up to the 4p, the 5s, and then take a look back over here, 4d, 5p. And I'm showing you those because this is when we're actually going to end up filling things in up to the 4p. So I want you to start getting comfortable using some of those higher energy levels. Here we go. Count to 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Watch what we do here. 13, 14, 15, 16, 17, 18. Coming over here to the 4S, 19, 20. So we're at 20. Where are we going to go? Some of you are thinking 4P. Nope. Look over here at the 3D. It's got less energy. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. We've got 5 to go. You're not going up here to the 5S, you're going to the 4P. It's almost like jumping almost like a video game. We've got 5 to go. That was 30, 31, 32, 33, 34, 35. And now we're done with the orbital notation for bromine. Last one, let's take a look at strontium. Look into group 2. See what you can tell me about strontium. It has 38 protons and electrons in a neutral atom, so you can imagine here we're going to go up even higher. We know what bromine looks like up to 35, okay, but this time we're going to go an extra 3. If I were you, I'd go ahead and hit the pause button and let's try this one on your own. Hopefully you've tried it, and here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. We've now put all 38 electrons into their locations, and that is the orbital notation for strontium. I hope you take a couple minutes to go back over these and maybe try doing a couple on your own, looking at a few of those practice links on Canvas, and then of course you've always got the PL assignment that you can complete for the extra practice as well.